live here. Let's do the retweet. Yep, there we are. One moment. Okay. Hello, everybody. Thanks for joining us today. Who's never been here before? First time? 4, nice. Pretty sweet. Okay, cool. How'd you guys hear about us or find out about us? Were you at the Virgo event on Meetup? Just stumbled across us? Okay, cool. That's good to know. Okay, well, this is Ethereum Vancouver. We've been running weekly meetups for over 3 years now, just to kind of have a place for people who are enthusiastic about Ethereum and crypto to come and learn and hang out. And this basement you're in is Decontrol, which is been around for over a decade as kind of a Bitcoiner hacker space, maker space community hangout. I'm sure Tango would love to give you a tour after if you're interested. There's a lot of history here, a lot of interesting characters have come through this place, at least famous in the crypto world anyways. And we're doing Ethereum 101 today because we knew some new people were going to show up. I'm not sure how familiar you are with Ethereum, but we're going to start from the basics anyway. I think we've done a lot of technical presentations and DeFi related things, and it's been a while since we did a beginner friendly presentation, I think. So, why is this happening? So Ethereum 101, it's helpful for me too, I think, just to kind of remind myself of the fundamentals. Sometimes you get so lost in the weeds and you work in the space and are so deep in it, you kind of forget about the high level stuff. So it was good for me to go through and try to remember all this stuff and how to concisely present it to somebody who might not be familiar. So that's what I'm going to try to do today. And I think we're going to try to do these things more often, beginner-friendly talks, and going to iterate on this. If you have any feedback for how it can be more accessible, or if there's anything that I can explain better or that I missed, happy to take feedback. I don't claim to be an expert. Yoni said he would be here to roast me, but he's nowhere to be found. Maybe he's in the back room listening. Okay, we're going to get started. I'm Christian. Some of my affiliations up there. Ethereum Vancouver, I'm one of the organizers, so I've been putting this on since inception. Again, it was February 2022, I want to say. And Superform is when I spend most of my time working on. That is a crypto protocol that I'm going to eventually get to showing you a little bit about today. I'm the head of ecosystem there. And then also a contributor to Hyperliquid Names, which is a name service on Hyperliquid. I don't know if we'll get into that today, but you can ask me about it later if you want. That's just some of the things I spend my time on in the crypto world, and that's my Twitter. If you wanted to give me a follow, feel free, or not. It's up to you. Yeah. Take your pictures. Okay, let's get into it. So I know this is Ethereum 101, but we're going to start with Bitcoin. This is the little outline of what we're going to talk about today. I think that it's important to start with Bitcoin because that was you get a lot of context by looking at Bitcoin that will help you understand Ethereum and the differences and why it's important. But Bitcoin laid a lot of the foundation and groundwork for cryptocurrency in general. And Ethereum kind of iterated on the success of Bitcoin. So we'll just start with what are the properties of Bitcoin, and without getting too technical, I'll try at least. The Bitcoin white paper originally called it a peer-to-peer electronic cash system. one of the most important properties, I think, is digitally native money. And what do I mean by that? Well, before Bitcoin, it was impossible to natively transfer value across the internet or digitally. Even you might think like you send an e-transfer to a friend, or you use like Venmo or PayPal or whatever, or you add money into your Robinhood account, and you might think that you're like digitally moving money, but like technically you're not, right? Like in the simplest example, you have, say I want to send some money to my friend via like an e-transfer or whatever. What's actually happening, right, is I have a bank, and my friend has a different bank, and each of those banks has like a ledger or a record of accounts, which shows how much money each of the customers of that bank has. So, sorry, I have like some kind of annoying like echo or ringing that's kind of throwing me off a bit. Sorry. So what happens here is, my bank will talk to my friend's bank and say, hey, Christian wants to send $100 to so-and-so. And what happens is my bank will take my account and deduct $100 and then tell the other bank that that happened, and then that bank will add $100 to my friend's account on their ledger. And so this is a simplified example. When you're looking at things like, say, like a Visa transaction, there's even more like layers of intermediaries that are involved and in like updating the balances of all these things. So there's a lot of things that happen behind the scenes that is like pretty inefficient. So you're not actually sending money digitally, whereas in comparison, when you're using Bitcoin, we say it's peer-to-peer. So like I'm sending value directly to you across the internet, kind of like you would send an email directly from one person to another. So Bitcoin is just like the first way that we could actually digitally transfer value in like an internet native way. Bitcoin is decentralized. Going back to the ledger at the bank, this is just like one single entity that has this record of accounts and full control over that. It's like this private database that's centralized, and we generally trust that the bank's not going to make any changes to the to this record in like a malicious way, but theoretically they could. Whereas the difference here is that in Bitcoin, the ledger of Bitcoin is stored in like thousands of different computers all over the world, so anybody can participate in the network, and they can keep a copy of this ledger on their computer. And this way we have a bunch of people who are all reaching consensus about what the state of this ledger is, about who owns how much Bitcoin essentially. And in this way, we don't have one single like point of failure or one single entity that can at a whim adjust the records on the ledger. It's permissionless. I hear myself somewhere. Bitcoin is permissionless, and basically if you have an internet connection, you can access the Bitcoin network, you can transfer value, you can store value, send Bitcoin to people, and that's the only prerequisite is I can access the internet. There's nobody who can tell you that you can't do that. You don't have to sign up for a bank account. You don't have to get permission from anybody to do this. You just access Bitcoin with an internet connection and you're good to go. It's also immutable. Again, this bank ledger, generally we trust, at least in our part of the world, that the bank's not going to maliciously alter the records, but they, again, nothing is really stopping them from doing besides like the social norms. And the Bitcoin ledger, on the other hand, is immutable or like unchangeable, basically. So it's essentially impossible in the way it's designed to adjust or to alter like a record of transactions on Bitcoin once it has been added to the ledger. Yeah, good, thank you. And it is censorship resistant, so if we take all of these previous properties like decentralized, permissionless, immutable, again, there's A good example would maybe be if you guys remember in the COVID truckers rally when they were protesting vaccines in Ottawa, and some people were trying to like send money to fund this protest, and they were actually their bank accounts frozen, right? Getting cut off from the financial system because of their political beliefs. It's not possible with Bitcoin. You can't like censor the network. You can't prevent people from using it because of these other properties. This is more like economics. So there's a fixed supply of Bitcoin. There's only ever going to be 21 million Bitcoin. And if you contrast this with cash, ever since 1971, so you used to be able to redeem your money for gold back in the day. In 1971, they stopped the ability to do that. And since then, purchasing power of the US dollar specifically has decreased by, I think, about 87%. So effectively, like $1 back then is like $8 today. So your purchasing power or the value of money has been slashed by 87%. And inflation is not that things are getting more expensive necessarily, it's that your money is becoming worth less. So Bitcoin, by having a fixed supply, it avoids this like inflationary environment that we exist in today. And then a couple other things is non-sovereign. So there's no single like nation state that controls Bitcoin as opposed to all other currencies in existence. So it's more like gold in that sense. It's like kind of like a global resource. And then similarly, it's borderless. You can send Bitcoin again across the internet. There's no geographical restrictions of Bitcoin. So these are some of the properties of what make Bitcoin unique. And these all apply to Ethereum for the most part. Oh no. Well, I've lost my slideshow. Angle. Shoot. Wait, I still have it on the live stream though. All right, how should we do this? I can't expect you all to look there. I guess I can like do this. Wait. All right. Okay. Can we get up there maybe?
Would you be able to plug in here?
Yeah, sure.
Because we're gonna all transfer to that.
Sure.
So if you just take everything over with, how is this gonna?
You tell me. All right. Sorry for anybody watching on the live stream. We have technical difficulties in person, so we're going to do a little switcheroo here, and we'll get back to you in a second. What do you have plugged into there?
Yeah, we need to plug this. Has to go. That cord has to get over there, and I don't think it's long enough.
Oh, I see. Wait, but can I just not? Oh, I guess can I not just plug it into however the TV? Like, what's the TV getting its input from right now?
You need to put your on.
On there. Oh.
You need to be in. Your computer needs to be on that.
Can I? Yeah, I see. For the live stream.
Only what we could maybe look at here is. Yeah, we're just gonna this screen. We're gonna send over here.
Okay. All right. So I'll just stay here then. Oh yeah, that's why. So this is the replacement for that, and they're both not great. So. I think he was just gonna put the whole stream up on here, basically. Yeah. So I promise normally this doesn't happen. We normally pretty dialed in around here, I want to say.
We had our projector die the other day, and we were using a that.
All right, cool. Can you get that full screen, perhaps? Or you could just pop over to the stream itself. This is running in the background.
Well, it's gonna be lagging.
Well, that's okay. Just, well, I mean,
Just let me go back to this.
You can send that to the screen.
all right, Dave's coming in.
Say like this. You make it. How do you do that? All
All right, we're gonna fix this in post. 9 people watching. No, 69 people. Wow, really? That's. How much does a stream lag by? I guess I can just see myself. All right, lags by quite a bit. All right, this is the best we got. 5 seconds? Okay. Well, let's see. I just changed the slide. All right, so there's like a 15-second delay. I have to like, I have to like predict when to switch my slides like before I go over. All right, we're just gonna go with it, I guess. All right, sorry about that, everybody. Luckily, we have someone here who's the owner of many projectors who's gonna hook us up with a new projector. Thank you. I feel like you were like meant to come into our lives today. Okay, moving on. So we're going to talk about some technical aspects of Bitcoin. We just talked about some of the properties of Bitcoin, and I'm not going to spend too much time on these because this is a talk about Ethereum. But again, for the context and the contrast with Ethereum, it's important, I think, just to talk about them. So I'll just wait for the slide to pop up there. Okay, so one is the blockchain itself. The blockchain is the ledger. We were talking a lot about ledgers and records of accounts and who owns what. So blockchain is a ledger, but it's a permanent and public ledger of all the transactions ever on Bitcoin since it launched. New transactions are added in blocks every 10 minutes. So like the data structure of this ledger is such that each block contains a certain amount of transactions, and then every 10 minutes, a new block of transactions is added to the ledger. And this is immutable and transparent, like we talked about, so it cannot be altered, and everybody can view it publicly and verify that what the state of the blockchain says it is like it's like this shared global source of truth. And the next thing that we have here is, are we all good? Oh, look at that. Nice. Okay, so the next thing is the security. What makes Bitcoin secure? And by secure, I mean like how can we ensure that no one is able to like alter the state of Bitcoin, or send themselves the same Bitcoin twice, or like spend the same Bitcoin twice. How do we make sure that this thing is working as intended? And this is called proof of work, is like the consensus mechanism. It's like how we come to consensus on what the actual state of the ledger is. And you might have heard that this is essentially, they call it like mining, as like an analogy for how you might like harvest gold from the earth. And essentially, I feel like I should be like over there, but I guess you can see me up there. So the miners, like, to put it really simply, they're solving these like complex math puzzles. It's like it takes a lot of like computation and energy, but it's not actually like that complex. You're not like doing like calculus or anything like that. But so basically, you have a bunch of people kind of racing to solve this problem, and then whoever does that gets to be the one to essentially create a new block and decide which transactions end up in this block. And the reason that we have to have this, basically it's like a resource constraint. We have to have some kind of, you have to spend something in order to participate in this system. And because it makes it very expensive to kind of cheat and try to alter the record of transactions. Because it's an open system, technically anybody could go in and try to say, oh, this is the actual state of the ledger. But if we have this like resource constraint to actually being somebody who can do that, then it is very expensive to do anything malicious and alter this like global source of truth that we have. That's probably the simplest way that I can put it. And then you get Bitcoin as a reward if you're the one who does this. So it's kind of, again, we say it's like mining and like analogous to gold, because you're spending resources, which in this case is like electricity and hardware, to get Bitcoin, which is this resource. And you're doing that. By doing this, you're participating in the security of the network. And by security, again, we mean you can like know for sure that this ledger we're looking at is the actual ledger that we all agree upon. I can't make things up. I can't spend the same Bitcoin twice. So that's proof of work. This is important just because Ethereum works in a different way, which we'll talk about in a bit more detail. I just wanted to mention this. And the final thing is public and private keys, or this is like the cryptography. When you think about cryptocurrency, this is for ownership and access. So really simply, you have two keys that kind of represent your account or your ownership of your funds. The public key, you can look at it as like a username or like an email address if you want to look at like email, and then the private key is a password. So the public key is public. Everyone knows, well, at least everyone can see your public key. They might not know that it belongs to you, but it's like there for everyone to see on the ledger. That's what everyone sees in the ledger. The ledger is essentially public key, and then how much Bitcoin does that public key own, kind of. And then the private key you should never share with anybody, because that's like the secret password to kind of unlock your account. In order to send a transaction, in order to send somebody Bitcoin, you have to use the private key. So again, this is very similar to how Ethereum works. There's public and private keys as well, and this is how you access your account. Okay, that's all the Bitcoin technical stuff we'll talk about. Let's actually talk about Ethereum now. Okay. The Ethereum white paper came out in November 2013, and this was by Vitalik, who you might have heard of, and it was called the Next Generation Smart Contract and Decentralized Application Platform. Now, what does that mean? Well, very simply, it's about using blockchain for more than just money. Bitcoin, at least back when this came out, it still is, in a way, very limited in what it can do. Essentially, it can store value, send value, right? Those are the two things it can do. And because Ethereum was built in we call it a Turing-complete programming language, that just means that we have a blockchain that can be programmed to do anything. So we still have this like public ledger. We have this decentralized global state where we're all like agreeing on this source of truth that we can all verify publicly. But instead of it just being a ledger for recording who owns how many coins, it's more of this like world computer that can actually run programs and execute programs to build applications, and we'll kind of dive into what that actually looks like. We'll kind of build it up, and we'll start with some Ethereum core concepts. So we'll just like cover like concepts, and then hopefully it kind of all ends up going together and it makes sense. If you have any questions along the way, feel free to stop me and let me know, but we're just going to keep going if not. The wallet is, you can look at it like your interface to interact with and access Ethereum. So your wallet is how you access your account. It's how you sign transactions. It's how you interact with these applications. You can kind of look at it like a crypto browser. And importantly, and often misunderstood, is that this wallet does not hold your assets. It just holds the keys to access them. So the wallet stores, we were talking about the private key, which is the password to your account. The wallet just like stores that private key and makes it easy for you to interact with Ethereum and send transactions. The assets, they're not really held anywhere. It's a ledger. So what you have is you have a record of who owns what on the blockchain, on Ethereum. And my assets aren't really they're not in a location. It's just this database that says my account is the owner of this many Ethereum tokens, right? And then if I have my private key, which is held inside of my wallet, now I can actually spend those assets. And we'll look at what that actually looks like in practice. But on the right side there, you can see an example of what this is the Rabby wallet interface. You can see like the balance, and you can do a bunch of stuff. You can swap between two different currencies. You can send currency to somebody else. You can check your transaction history. There's a bunch of other things in there. The next thing we'll talk about is accounts and smart contracts, because remember we were saying that back here, a next generation smart contract and decentralized application platform. So what does that mean? So we were talking about accounts already. You can think of accounts as like entities in Ethereum. Again, this is wrong. They don't hold assets. I shouldn't have put that there. But in a way, they own assets. They have ownership of assets, and they interact with the network. So these are entities. This is your identity on Ethereum, and there's two different types of accounts. If you're doing things on Ethereum, you have what's called an externally owned account, or an EOA. And then the other type of account is a smart contract, which is, rather than being controlled by a user, this is controlled by code. And an account on Ethereum, on the right side there, you can see what that looks like. So it's just 0x and then a string of letters and numbers, 20 bytes. And that's what an Ethereum account or an Ethereum address is represented as. Every externally owned account, every smart contract will have a unique one of these. And if you're using Ethereum, you are identified by one of these addresses or accounts. It is derived from the public key. We were talking about public and private keys earlier, so that is a kind of a representation of what your public key is. And this is public, right? So on the ledger, again, it's all based on this digital decentralized ledger. It's going to have this address, and it's going to show, what this address has ownership of, what it has, like what assets it has a claim to, essentially. So an externally owned account, an EOA, is controlled by a private key. So that's my public key, and then if I hold the private key, I can access the funds that are owned by the account. So I can send and receive ETH. So ETH is like the native token of Ethereum, kind of like on Bitcoin. You have Bitcoin. I can send. You have the Bitcoin network, but also I can send and receive Bitcoin. Similarly on Ethereum, the network's called Ethereum. This blockchain ledger is called Ethereum, but we also have this ETH token, which can be sent and received, and we'll talk about in a sec, is also used to pay transaction fees in the network. And then we have other tokens. We'll dive into that as well. Besides having ETH on Ethereum, because it's programmable, we can have currencies that are not the native currency. An EOA can sign transactions. again, to send tokens, but also to interact with smart contracts. And then an example is we looked at, this was Rabby here, but a familiar one is MetaMask as well. It's another browser extension wallet that you can interact with Ethereum with, and you're going to have some address that you're using when you're using MetaMask. By contrast, we have smart contracts. Now, these are not controlled by users. This is code that is stored on the blockchain. So we can actually have these programs that exist on the blockchain, and they are accounts, so they can hold assets just like an EOA can, but they also execute logic. And these are programs that just have like inputs and outputs. So they receive some instruction and they execute some arbitrary logic. A really simple example can be like swapping between two tokens, or some more advanced things we'll talk about later are like decentralized finance applications. If I want to like borrow or lend money, or we won't talk too much about NFTs, but if you've heard of those, we can interact with non-fungible tokens. I'll give more examples, and we'll do like a demo later, and this will all make sense. But essentially, just understand that this is code on the blockchain that can run some program. It's not able to like sign transactions itself, and it's autonomous. Basically, users or EOAs interact with these contracts to make things happen, and to like alter the state of the ledger in interesting ways. I mentioned transaction fees earlier. We have gas. This is like the fuel that powers action on Ethereum. So remember, we're not just sending value. We're actually like executing programs. We're executing code, and this has some sort of computational resource requirement. And actually, because this is like a decentralized ledger, everybody who's running the Ethereum software to maintain that ledger and have a copy of the ledger, they're running these same programs. So every time you do something on Ethereum, whether that's sending tokens or swapping between two different tokens or currencies or interacting with a smart contract, you need to pay a transaction fee. And the more complex this operation is, so if you're just sending Ethereum from one person to another, that's probably like the least complex thing you can do, and that's very cheap in terms of gas. But if you're interacting with a complicated smart contract, then that's going to be more expensive in terms of gas. And gas is paid in ETH, which is like the native token of the network. And in order to get your transaction processed, you have to pay that fee. Now we'll talk about consensus and execution. It's not like that technical, although it might sound like it. Basically, consensus is agreeing on the state of the chain, and execution is updating the state of the chain. So we talked about proof of work for Bitcoin earlier, and this is just like a mechanism by which we don't have this like centralized entity with this database that is deciding that this is the state of the database. We have everybody in the world effectively who is agreeing on this state of this decentralized ledger. So what is the mechanism by which we come to agreement on the state of that ledger? What is the order of transactions? Like, because the transactions have to occur in a certain order, right? One after the other. And what blocks are valid in this chain of blocks? Like, what makes something valid and not valid? And most importantly, like, who owns what at each point in time? Remember, this is like, we have this state of this ledger, and we have to be in agreement of like, I own this many Ethereum, or I own this many of whatever token. And everyone has to be on the same page, right? So through consensus, we all achieve this, shared source of truth. And then execution is then updating the state of the chain, running the code essentially. So taking instructions from transactions, sending funds from one account to another, and interacting with this code, these smart contracts on the chain, which do more advanced alterations to the state, and then processing them and applying them, and then updating the state. And so every time that a new block occurs, which in Ethereum is much quicker, it's seconds as opposed to 10 minutes in Bitcoin, we update the state of the blockchain. So we need to execute all the changes that happen between blocks, and we need to have consensus on the state at any given time, or in the current moment, rather, but also the chain of events leading up to this. And how do we do that? Well, I guess here's a little table that has the differences. So basically, an analogy for consensus is like, again, that like ledger. How do we agree on the state of this ledger? And then for execution, it's more like a calculator or a computer that's actually executing and processing transactions, processing these smart contract logic, and making changes to the ledger. And this is through the proof of stake consensus mechanism. So proof of work was through expending energy, electricity, and having hardware that allowed you to do this like energy intensive process, which we referred to as mining. Ethereum actually used to run proof of work. This was the same consensus as Bitcoin, but we realized that it was maybe not the most efficient way to do things. It was very resource intensive, and the fact that like Bitcoin uses more electricity than the majority of countries in the world. So proof of stake is a way to do it much cheaper. And what's why the stake comes in that you put up your assets. Basically, you stake your assets. So I have the minimum you have to stake is 32 Ethereum, and I essentially, it's like a security deposit. I like put that up, and I say, okay, this is like my commitment to the network, and I'm going to act like the miner in the Bitcoin scenario, but without having to spend all that energy. Rather, I'm like putting my assets in this security deposit, and I'm just going to validate. I'm going to take these transactions that are coming in, I'm going to validate the state of the blockchain, and I'm going to be proposing and creating these new blocks and updating the ledger. And if I misbehave, if I act maliciously, I can get slashed, we call it. So essentially this money that I put up, I can lose some of that. And so that's how we keep people honest. And then if you are honest, similarly with how the Bitcoin proof of work mechanism worked, proof of stake, honest validators, rather than miners, are rewarded with Ethereum. So this is the way that consensus works. I stake my assets, I participate in validating transactions and creating new blocks and updating the blockchain ledger. And then if I do a good job, I get paid. If I do a bad job, then I can lose the money that I put up for stake. And here's a comparison of proof of work versus proof of stake. Miners versus validators. I don't have to use electricity and hardware. I just put my Ethereum up for stake. I'm just validating the transactions. I'm not solving anything complex. And the energy usage is like, it's like 99.9% cheaper to do proof of stake versus proof of work. It's exponentially cheaper, or to not have to mine the currency. So it's a much more efficient way to do things, but there's some trade-offs. We're not going to dive too much into it, just accept that this is Bitcoin does proof of work. Ethereum used to do proof of work, switched over to proof of stake, and has been doing that for a few years now. Everything's going great. And the whole cryptocurrencies destroying the environment argument kind of went out the window when that happened. So we don't talk about that one anymore so much. The last core concept, I believe, is tokens. I was talking about tokens earlier. We have like the native Ethereum, which is it's kind of like the Bitcoin of the Ethereum network that we use for paying transaction fees. But then we have these tokens, and through smart contracts, we can create a totally different currency that exists on Ethereum. So these are digital assets built using smart contracts. And the contract, in the case of a token, defines the rules of the token. So you can say the total supply. So like there's going to be 1 billion units of this particular token. And that's coded into the smart contract, or rules around transferring. It can be anything arbitrary. Usually they're pretty simple, but you can have whatever kind of logic you want in there. Sometimes there's like transaction fees like baked into the contract itself. An example would be like if I ever want to like send this money, if I send like 100 tokens to you, take 1% of that and distribute it amongst all other holders of the token, for example. It can be any arbitrary logic. Generally, it's pretty simple and they're pretty standardized, but anything is possible. They're just like the Ethereum token, you can send, receive, trade, use them, just like that. These are your cryptocurrencies, these are your digital assets. And there's a lot of different types, but there's two primary types, which are ERC20 and ERC721. Those are technical terms. What those actually mean is fungible and non-fungible tokens. So ERC20 are fungible tokens, digital money, digital points. Those are on the right side. Those are actual cryptocurrencies. That's USDC, wrapped Ethereum, USDT, and then the Uniswap token. But other examples of fungible assets, rather, you have cash, gold, Bitcoin, oil, natural resources, stocks, shares. And so fungible tokens, all units are identical, like 1 USDC equals 1 USDC. They're nearly infinitely divisible, so I can send 0.5, 1.25 tokens. And the balances are tracked in a single mapping. Think of it like a spreadsheet, which has addresses and balances. We've kind of talked about what that might look like on a ledger. I think I actually have an example, yes. So what this would look like on the ledger is address, address 123, and that's their balance. So, this USDC token, I can say this address owns 100, the next address owns 100,000, the next address owns 69 tokens, and this is all recorded in the ledger. And then if I send, say that first address sends those 100 tokens to the second address, now in the next block, the state of the ledger is updated, and this will instead have 0 for the balance of the first address and 100,100 for the second address's balance. On the other hand, we have ERC721, which are non-fungible tokens. Non-fungible is like completely unique. So like a plot of land or the Mona Lisa, rare pieces of art, or collectibles like baseball cards and Pokemon cards. Every token has a unique ID in this case, rather than them all being the same. They are all completely unique, at least in the sense that on the blockchain within the smart contract, each one has a unique ID. And they're not divisible. Each NFT is one whole token, can't be split. And ownership is tracked individually. And here's what that looks like on the ledger. So rather than each address having a balance, rather there's each token from a particular contract has an ID, and then that ID is mapped to the owner of that ID. So in the case of Bored Ape Yacht Club, which is these on the left side, the monkey there, essentially this is a non-fungible token, and each one has a unique piece of artwork that's attached to it. And each one of those has an ID, and this is all enforced by this smart contract. So the smart contract has all the rules for the fact that there's only ever going to be whatever it was, like 10,000. I can't remember exactly. Bored apes, yeah, 10,000. And then you can. So there's 10,000 tokens that this contract is accounting for, and each one has a unique ID from, I guess maybe it starts at 0, maybe not 1. So we go 0 to 9,999, and then each ID is owned by a particular address. Okay, we're going to do a little demo. We've been looking at my slides for a while. So we're going to look at Rabi Wallet. We're going to send and receive ETH and ERC20s. We're going to look at a block explorer. So what do I have here? Here's Rabby. You see that? I guess not too much. Can I make this any bigger? I can't make this bigger. Maybe I can. No. Also, it's not loading, but. No, wait. Oh, yeah. We were just looking at this the other day, weren't we? That would be bad. I can't recall. Oh, yeah. It was here, yes. Yeah. And then I wanted to go. No, oh, wait, I remember what I had to do now. It was, wait, here, we go here. No. Yeah. Here, and then we do this. Okay. There we go. Okay. And I think, should I keep the index, or just this? Oh, lost it. All right.
You can basically bookmark the ID.
Yeah, this is not like, I can just interact with it from my browser extension here. I'm just trying to get it into a full window so you guys can see it. So this, don't let this reflect on the UX actually. Okay, voila, and now I think I should be able to pop this up. Okay, there we go, look at that. So here's the Rabby wallet. What you can see is my dollar balance here. I can look on Ethereum and see what assets I hold. So here's my Ethereum balance. Here's my USDC, DAI. These are all ERC20 tokens that you can see that I hold in my wallet. They're all these are all different tokens with the amounts. I can see here, these are applications that I've interacted with. So Rabby is pretty good in that it tracks applications that I'm deposited into, that I've used in some way. Maybe I'm I've lent my assets into a particular application or otherwise using them in some way, and it tracks that as well. We'll look at other chains later too, but beyond Ethereum, I can look at other blockchains. It tracks that. We're just focusing on Ethereum for now, I guess, or I'll probably actually use a different one so I don't spend a lot of money. And there's all kinds of things we can do in here. Do I have NFTs? I might. Oh yeah. So these are non-fungible tokens that I've got here. A lot of these are spams that people have just sent random things to my wallet. But you can see that you can actually view your NFTs, and it shows the collection it came from. It's got purchase date and all this, and so all this is possible to view within Rabby. But Rabby is a nice. We can do a lot better, but this is pretty good way to kind of see what's going on the blockchain. This is your interface. This is how we interact with the chain. So I can send funds. Oh, that's nice. So I'm gonna send 100,000 piggy tokens, and I'm gonna send them to. I'm just gonna look at this is my address book. So these are all my other addresses. I think I just created ETHBand demo. Or actually, I need to send Ethereum so that I can actually big ass. Okay, so I'm gonna send some Ethereum, $1.50 of Ethereum, to this address here, which is my ETHBand demo, and I send, and that's interesting how that pops up like that. This is because I've got it all zoomed in here. So what I've done is basically I'm sending requests. I'm sending a transaction to the chain. I'm saying, okay, I want to send this amount of Ethereum from my address to this other address, which I've input here. And now I'm signing the transaction. The reason I can do this is because, again, this is my address. Well, this is the address I'm sending to. I have my own address as well, and the private key, the password to this account, is stored in this browser extension. So I'm able to then just, through this extension, sign the transaction. And if I do that, now it gets posted to the blockchain. And it's going to take a few seconds to confirm. Actually, this might be weird. Okay. So I can see here in my transaction history that this has been sent. And we'll look at like a block explorer. So again, this is just another interface to see what's going on the blockchain. And so this is like transaction details. Don't worry too much about like the specific stuff going on here, but basically what you can see here is this is the action that occurred. I sent this much Ethereum to this address, and here's the from, so this is my address I sent from. This is the address I sent to. And now if I go to this address on the Explorer, I feel like the internet's slow or something. Well, there was that problem with base scan earlier, maybe it's not. Well, I can also see in the browser, in the wallet here, so going back to here, if I go to this new wallet that I created, there's the $1.55 that I just sent in, and that is in Ethereum. So that was just like sending the native token. I guess I can also show you sending a different token. The reason I sent Ethereum first was remember, Ethereum is required to pay gas fees on the network. So if I just send myself a token that isn't Ethereum, I actually can't do anything with it because I don't have the gas to pay the transaction fees and then send it or do anything else with it. But now that I have Ethereum or gas on this account, now why don't I send another token to it? I'm going to do what I was going to do the first time. So I'm going to send piggy token, send 100,000 piggies to that same address, which was ETH demo. This simulates what's happening, so it simulates the fact that 100,000 piggy is going to leave my wallet. And now we can go back to the Explorer here if this is going to work. Am I a human? Okay, just slow internet. So, oh boy. All right, well, we're just going to look in here again. So going back to the ETH demo account. All right, I think the internet's just having issues. Well, okay, you can see my balance is updated here, right? And now I can look and see. There's the piggy tokens. So I'm pretty simple, but I've just sent two different cryptocurrencies from one address to another using a wallet, which is how we interact with the blockchain, and looking at an Explorer, they're going to track the movement of funds in a different way. Okay. Let's talk about a few other things here, moving on. Talk about scaling Ethereum. Why does Ethereum need to scale? Well, there's a lot of demand for, we'll call it block space, or demand to get my transaction included on this ledger and to send funds or otherwise interact with smart contracts. And Ethereum can only handle about 15 transactions per second. So if there's more than 15 transactions per second that want to be included on the ledger, then where these transactions are competing for this limited block space and demand spikes, this means fees skyrocket. So basically, I can pay more gas to get my transaction added to the blockchain sooner. But if we have a lot of demand and a lot of people willing to pay a lot of gas, now it becomes very expensive to actually get my transaction on Ethereum to work. You can kind of look at it as like rush hour traffic, or everyone trying to drive through a 1-lane highway at the same time. Picture as 2 lanes, but. So what's the impact here? High gas fees. It can cost. Sometimes we've seen it cost like over $20 in gas just to do a simple token swap. And that's not even talking about like more advanced contract interactions that might cost you $100. It can take a long time to confirm your transactions if you're not willing to pay that high gas fee. But this is like a huge UX problem, barrier to entry for people, for new users. So Ethereum needs to scale so more people can use it affordably and quickly without compromising its value. So there's a few different ways that Ethereum can or intends to scale. The main one we'll look at is layer 2s. So this is actually just a separate kind of blockchain built on top of Ethereum. Ethereum is like the layer 1. It's secure and decentralized, but it can be really slow. And it is the thing that ultimately handles the consensus. It stores all the data. And it's the final settlement layer that is like this source of truth. But we can build a separate blockchain on top of Ethereum. And the execution occurs here. So we do the transactions on this other chain that doesn't clog up Ethereum. We can do things cheaper and faster, and then we take the results of all that at regular, this like intermittent schedule, and then send that back to Ethereum and say, hey, this is the result of all the transactions that occurred on this other chain, and we're posting this on Ethereum as this final source of truth. Do I have another slide on that? Yes. So like a side street, this highway is clogged up. I'm going to take this like side street to go faster. So users actually, like I was just doing actually, you saw the transactions I just did weren't on Ethereum. They were on Base, which is a layer 2 chain that is much cheaper and much faster than Ethereum, and then inherits the security of Ethereum because the L2, Base in that case, batches a bunch of transactions together and then sends the result of all those transactions to Ethereum. And that is the final record stored on Ethereum. So this just has lower gas fees, faster transactions, still inherits Ethereum security because we're ultimately storing the records of what happened on Ethereum. And this is the current best way for Ethereum to scale to millions of people. Okay, and the final thing we're going to spend some time talking about is DeFi, or decentralized finance. And essentially, through smart contracts, we can build these financial applications on blockchains that anybody can use with no banks, no middlemen. So this is essentially finance that it's inherited all these properties that we were talking about: decentralization, permissionlessness, censorship resistance. And again, same thing, anybody who has an internet access can now access the world of finance. You don't need a bank, you don't need a credit score, there's billions of people in the world who are unbanked or underbanked, and that they don't have access to the financial services that we take for granted every day. And DeFi is a way for them to kind of be on the same playing field. And all this runs on smart contracts. This is the code on blockchains. So we can have software that runs on Ethereum that allows us to do things like, again, simply sending tokens between accounts, but also more advanced things like, lending money to earn interest, or paying interest to borrow funds, or more advanced things like that. This is all transparent, global, open, 24/7, open source, composable, so you can build apps on top of each other. It gets kind of cool with all the things you can do. But essentially, you can do everything you can do in traditional finance and more. You can do it faster, you can do it cheaper, and without asking permission. Only possible on Ethereum. And this is just a list of some of the things you can do with DeFi. Swap tokens, provide liquidity, lend assets, earn interest, borrow assets, trade assets, yield farming, which is just kind of automatically trying to find strategies that earn the best interest on your assets, doing it in like an automated way. We have stablecoins, which are ERC20, like fungible tokens that are pegged to the US dollar typically, or some other stable asset. Automated investment strategies, tokenization. We can take real world assets like stocks or other like loans and things, and we can put those on blockchains to be traded in this more open, permissionless, efficient way. And we're going to look at two DeFi primitives, which are kind of like the lowest levels of the stack of the financial applications that exist on Ethereum and other blockchains. And a decentralized exchange is the first one, or a DEX, which lets you trade crypto assets directly from your wallet. So this runs on smart contracts again, no banks, no middlemen. It's all peer-to-peer, as crypto is, trustless, and you can keep full control of your assets. Unlike anything that's not blockchain related, there's some kind of middleman who's facilitating the exchange, unless you're using like physical cash, and you don't have control of your assets. It's for some point in time or ever. There's always somebody custodying them or handling that for you. And on the right side, that's like a Uniswap is a decentralized exchange, the most popular one, and that's the interface for swapping between two different tokens. Now let's talk about how these decentralized exchanges actually work, because how can you trustlessly swap assets between or trade assets with somebody else without a middleman facilitating that? How do we actually do that? So we have this concept of an automated market maker and liquidity pools. I have this nice little diagram that I made to show what that looks like. So the liquidity pool itself is a smart contract. And in the liquidity pool, the simplest example is you have two tokens. These are fungible tokens. And in this case, we'll say that there's an equal dollar amount of each token, of token A and token B in the pool. So we have, for example, 5 token A's worth $1 and 1 token A worth $5. And again, this is a smart contract. So this is kind of like a robot who is operating this pool. And remember, smart contracts can hold and move funds. So it's kind of like this robot has his own wallet, and that's holding these tokens in this pool. And now say I have, that's me, and I have token A, and I want token B. And I can pay some transaction fee to this pool, and I can basically move my A into the pool and get my B out of the pool. And I'm doing this on the blockchain. I'm interacting with the smart contract. This is all permissionless, trustless. But how does the money get there? Who's on the other side of this? Well, these are the liquidity providers. So you can either be someone who's swapping tokens in a liquidity pool, or you can be someone who's providing liquidity, and that's essentially funding the pool, putting assets in the pool so that the other person can come in and make that trade. So what they do is they'll supply an equal portion of token A and token B. So I'll put like $100 of token A and $100 of token B into the pool, which then allows other people like me to come into the pool and trade between A and B. And then those transaction fees paid by the person doing the swapping is sent to the liquidity providers, the people who are putting the funds up to facilitate this trading. And they get a separate token. It's called an LP token, or a liquidity provider token. And that's just like a receipt token or a representation of their shares of the pool. So this is like the best way I can visually describe what's happening in a liquidity pool or a decentralized exchange. This is kind of like the simplest implementation. A lot of different things exist now. But that's essentially how it works. You have these, and this is all happening in a decentralized, trustless, permissionless manner. Anybody can come in and swap tokens. Anybody can be a liquidity provider and earn funds from this pool. And this all is executed through this smart contract. The smart contract determines the rules of how all of these things take place. But there's no middleman, no bank, no centralized entity in the middle facilitating this. It's all just done on the blockchain via code. And the final thing we're going to talk about here is lending and borrowing protocols. So in DeFi, we can lend your assets, your tokens, your funds to earn interest, just like you can in real life. Or you can borrow assets and pay interest. And because we're not using a bank, because there's no like credit scores to determine your credit worthiness, typically these loans are over collateralized. So say I want to borrow $100, I have to put up collateral, or say I have to deposit $150 of my own funds, and then I can borrow against that. And I can borrow $100. We'll do a demo after this, and we'll see what that looks like. So how lending works, I'll deposit my crypto into the protocol, it goes into the smart contract, and then specifically this is a liquidity pool, and then borrowers can use those funds that I've deposited into the pool, and then I earn a share of that interest based on how much I've put into the pool. So it's deposit money, earn interest, but in a decentralized way. And on the other side, you have people borrowing from that money I put in. Again, they have to put up collateral first, because otherwise, how do we make sure that they'll ever pay the money they've borrowed back? So you borrow less than your collateral. These are over-collateralized loans. And then if your collateral decreases in value, you can get liquidated. So if essentially, I put up 1 Ethereum, and then that's worth like $1,500, and I want to borrow $1,000. So I put a 1 Ethereum into the pool, and I borrowed $1,000, and I can go do whatever I want with that $1,000. Now, if my Ethereum decreases in value, and now that's only worth $1,000, well, the protocol is designed such that I have to be able to pay the money back. Otherwise, there's bad debt, and that kind of ruins the whole system. So I'll get automatically liquidated by the smart contract, and I'll lose the collateral that I put up, that 1 Ethereum. So let's look at what some of this looks like. I know we're getting a little late here, so I'm going to go a little quick through this, but I just want to show you some things we can do. So first we'll look at Uniswap. All right. Is there like a different internet I can connect to besides the members room maybe? Like, I'm on 5G. Should I try regular? Too many humans. No internet at all on this one. Oh, all right, here we go. Okay. Okay, so we saw this in the slide before. This is a swap interface. I'm going to connect my wallet. Am I on this ETHFan demo? Yes. Okay. So I have Ethereum, and I can swap for any token. In fact, because we're using that ERC20 standard, any token that is designed in that same way can exist here. So there's actually thousands and thousands and thousands of tokens here that like some crazy Claude Monet memory coin, like, just random shit. Most of it's trash garbage, but a lot of it's, somewhat legitimate. So I have wrapped Bitcoin, which is kind of like a proxy token worth 1 Bitcoin through some mechanism that we won't get into, but I can swap some of this. So why? Oh, am I on the wrong chain or something here? What does this mean? Wait. How do I? Wait, how do I change? How do I change chains on Uniswap? Why don't I?
You have to go to your wallet.
Oh, okay, it's just directly in Ravi. Okay, all right. So we're using Base again. We're using a layer 2 because Ethereum, it's not that expensive right now, but I'll probably pay like $1 or whatever in fees. I don't want to spend that much money. I want to do things for very cheap. So I feel like I'm still on Ethereum though. Wait, because I feel like, I don't know why, but here's the tokens in my wallet on Base. Why? Okay, we're saying screw Uniswap. We're giving up on Uniswap. Instead, we're going to go to CowSwap. Okay, that's fine. Okay. Don't get milk. This one's more fun anyways. It's like there's cows and stuff. Okay. Trade on CowSwap. Okay. Same thing. It's gonna be a swap interface. Connect to it. Okay. And this, see, this is dumb. Why did Uniswap not have like a? How do you? But how do you change your chain? How do I? But where's my? Oh, why was this not showing up before? Oh, I see. All right. Okay. It's too advanced for me, actually. Okay. Okay, I want wrap big. Okay. All right, but here in this case, this looks like it's. Oh, here we go. Oh, all networks. Got you. Okay. Voila. Yeah. Is there even a wrap Bitcoin on base? These look sketchy. Yeah, you're right. You're right. All right. Okay. Okay, so I'm going to swap some of my Ethereum for some CBBTC. And this interface, once I got it figured out here, it makes it very easy to do that because, again, we remember like what's happening behind the scenes. Well, it's actually code that's running, and we're like interacting with a smart contract. But you know, this is kind of the visual representation of what is happening, but it's all simplified here in that I can just swap. The swap might fail. Sometimes. I think it might be like an internet thing here again. Okay, let's use CowSwap. Oh, I got disconnected. Okay. And then we want to use the base chain. Here's my ETH. I want to swap to Coinbase Bitcoin. Gas free. I don't have that much ETH. Okay. And I confirm, and then this pops up the wallet here. Oh, sorry, I could be more zoomed in. And we're signing. And again, we can look at the transaction if we wanted to on the Explorer. Going, yeah, well, we'll see it in here. Oh, my sound was off. Wait, we can do another one. All right. Okay, so why don't I just swap that back? You don't think so? Oh, jeez. Okay. All right. Anyway, yeah, let's see. Is this updated here? Okay. So here again, we're looking at the Blockchain Explorer. Oh, this is create order. I wonder. Okay, so in my wallet, you can see I've made the swap. I have this Coinbase. The other day, there was like some issues with the base Explorer, and I feel like it's still having issues because it's not showing this transaction that just occurred. But you can see in my wallet, maybe you can't see, but I promise that right there, that's the Coinbase Bitcoin that I just swapped for. Okay. Anyway, that's swaps. Let's look at Aave now. Last thing here, we'll do some lending. So. Okay. And on Aave, what we have here, we have the market. So on base chain, which is again Ethereum L2, here's all the assets that I can either lend or borrow. And I have this, these Ethereum, Coinbase, Bitcoin that we were just interacting with. If I go to my dashboard, I can just see the assets I hold. So what we'll do is we're going to lend. I can lend this Coinbase Bitcoin, and I can earn 0.03% interest. That's really good. So we're going to do that. You really get humbled with crypto UX when you try to do it in a demo. Okay, so there's two transactions I have to do here. One is I have to approve. So I'm approving the Aave smart contract to essentially spend my money, or the token contract rather. But I have to approve the smart contract to give it permission to move my money. And once I've done that, now one more transaction to actually put the money into the pool. So I'm taking that Coinbase Bitcoin and it's going into that pool, and I'm receiving this like receipt token, which is a receipt of my deposit into the pool. That's how we just keep record of things on the chain. So this token goes, this CB Bitcoin leaves my wallet. I get this receipt token into my wallet, and now this should show up. Should show up there. Maybe it probably doesn't show up. In any case, you can see here, now I've got this, I'm earning this interest. And so I have, this is my collateral, right? I have this 77 cents we were talking about that I have to borrow money. I have to have collateral. And so now I can borrow any of these other tokens here. So let's borrow, would be cheap here. Well, I can borrow more Coinbase Bitcoin. So I deposited this Coinbase Bitcoin into Aave, and now I have the ability to borrow some percentage of that. So it's I deposited 77 cents. That lets me borrow 55 cents. I can do that. Do this. Okay. I acknowledge the risks involved. Okay. Do this. Okay. So now you see this in my dashboard here. Boom. So, okay. So this is my supply position. I'm supplying this much. And now I've also borrowed this much. So my total exposure to Coinbase Bitcoin is now almost doubled. This is my health factor here. So that's like red. So that's pretty bad. Basically, if this drops below 1, I get liquidated. Because I've used all my borrowing power. So if the value of Bitcoin decreases, I could lose this collateral that I put up. But anyways, the whole point here is I've done this. I didn't have to ask anyone permission. I didn't have to open a bank account. I just had a wallet. I had an internet connection, and now I am doing finance stuff. I'm trading with people. I'm lending my assets. I'm borrowing assets. And that is the basics of DeFi. There's a bunch of other things you can do on top of that. We're basically almost at 8 o'clock here, so I'm not going to do anything else, but I have one more slide to show you. And this is, what's the point of all this? I mean, hopefully you got a little bit of it, but just to like kind of really drive it home, here are some examples of like, what does this unlock? We have this cool thing, Ethereum, and I talked about all the different ways that it works and the different aspects of it that are like, you know, pretty technical, and you don't really have to understand any of it to like actually understand why it's important, but it's like good to know and kind of cool. But here's some interesting, exciting things that this enables. Financial access, we talked about that. For people who are you know, in a position either geographically or economically or otherwise where they don't have access to the financial infrastructure that we take for granted today, they, if you have, all you need is an internet access, and in, you know, a lot of places in the world where you might struggle to get a bank account, or you might not be able to trust your government or the banks or the financial institutions in your country, a lot of the people have smartphones and internet connections, so they can participate in finance now. And if you have stable coins, if you have a hyperinflationary local currency, you want exposure to US dollars, you can get like a stable coin, which is, you know, we were looking at USDC, USDT. These are tokens on Ethereum that are pegged to the US dollar. And if I have an internet connection, I can store my value in essentially these digital US dollars on Ethereum blockchain and not have to have exposure to my hyperinflationary local currency that's like inflating by hundreds of percentage and destroying my purchasing power. We have tokenized real world assets, so we can put real assets on the blockchain and now use these like efficient ways to like trade and trade assets and record ownership of assets for things in the real world, not just for like digital tokens. So we have some cases of that today where it's mostly like loans, like loans to kind of mid-market companies. These can be tokenized, and now you can kind of access a part of finance that is typically reserved for like institutions and like accredited investors. Now anybody can kind of access this different asset class, but that's just scratching the surface. We expect to see stocks tradable on chain, unlocking like deeper liquidity and efficient trading and 24/7 markets for all assets in the regular financial world. Bonds, T-bills, all of this likely is already coming on chain. I think trillions of dollars of all these assets will be on chain within the next 5 years. We have digital proof of ownership via NFTs. So for the first time ever, you can like actually prove you own some digital item. And even beyond that, we can have ownership of real estate, for example. You could have your house deed on chain today. The only reason you own your house is because some like government registry in their ledger says that you are the owner of this piece of property. But maybe we can have that in like a decentralized manner. Lots of things we can do with NFTs, like even as simple as like ticket sales, fixing like ticket scalping, proving that I'm actually the owner of this ticket or this ticket is authentic. We have DAOs, which are decentralized autonomous organizations. So this is like transparent on-chain governance. We can have corporations or government entities that do their voting and governance on chain, so that it's transparent, that everyone can see it, anybody can participate. That has a ways to go before that sees like real mainstream adoption, but there are DAOs that exist that do governance on chain. There's decentralized organizations that anybody can join and through holding this like governance token participate in. We have digital identity. I like to think that you're gonna have like true ownership of your identity documents. Again, like you, your driver's license, your passport, that can be represented as an NFT on chain. And then composability, interoperability. Just because all this stuff is like based on code, it's programmable. So the possibilities are limitless. Anything that you can program can be created on Ethereum, and we're just scratching the surface of what's possible. And every day something new and innovative that does come out. A lot of it is experimental and doesn't end up working out, but the point is like we can continue to build things on top of Uniswap and Aave and all of those protocols we looked at. And for today, we can kind of mimic all of traditional finance on chain. Tomorrow, we'll build entirely new financial structures and applications that aren't even possible in the traditional world because this is all programmable and composable. So, hopefully that's a little bit inspiring. Anyway, that's about all I had for you. If you have any questions, happy to answer them. Hopefully that was interesting and inspiring in some way. And thank you all for coming out. Sorry for the technical difficulties. You can face this way now. Yes, sir. Give this man a microphone.
Perfect. Okay. Well, thank you very much for the presentation. Really insightful, and it feels really good to have like a refreshment on all those knowledge. Mm-hmm. Maybe it would be interesting if you can, like, really maybe high level and briefly talk about essentially the risks associated to using like Ethereum, DeFi, and how eventually you can best prepare yourself or like have the best practices.
Sure.
Right?
Yeah, lots of. So when we're dealing with this like decentralized world without intermediaries and middlemen and centralized entities, there's a lot of benefits that I talked about, but I guess that also comes with a lot of like potential trade-offs and risks. One easy one is we have this concept of like a public and private key. So I have essentially this password that unlocks my wallet that could potentially have millions of dollars in it. And if I lose that password or access to my account, there's no way to ever recover that. So like that's like, you know, the pretty basic UX. Like there's a lot of solutions that exist today for better management of your private key. But if you want to be like fully self-custodial with your assets, you don't have the safety of, say, if I lose the password to like my bank account, that's not a big deal. That's easy to get. If somebody somehow defrauds me and steals the money in my bank, or I otherwise lose funds that I've invested, there are some investor protections that exist for those assets, or protections for deposits in my bank account. Those don't exist in crypto, at least not today. You can like purchase insurance, but it's not like by default. Because we're interacting with software, these smart contracts, there can be bugs in the software. So if I'm using some newer DeFi protocol or even an old one, it could be that there's some sort of way to exploit it, and there's always like hackers looking for ways to like steal these funds. So you can interact with something that's just by nature malicious, and it can just steal your funds. Or I can have my money deposited in one of these liquidity pools, and some hacker can find some bug in the code and use that to steal my money that's deposited in there. And then again, there's no real recourse. I can't do anything about it necessarily. I might get the money back, it's possible, but in a lot of cases not. Some of this stuff is like legally gray as well. Like the jury's still out on how to properly like account for this stuff, like in terms of what the CRA's rules are for doing this DeFi stuff. I mean, even I feel like those things that I just did now on the demo are probably like taxable events. So. Yeah, I know, but it's permissionless. I can do whatever I want, right? But yeah, so there's like some legal considerations. It's getting to the point where it's like pretty widely accepted, but there's a lot of stuff is like very legally like gray, I would say, in terms of like what. Not like illegal necessarily, but how do I properly like report this stuff in terms of my taxes, for example. There's a lot of uncertainty around it in that sense. Does that answer your question? Anything else you would add there?
Yeah. I mean, I think maybe one thing that can be interesting is as it's code, there's also a huge part of the industry that is audited. Mm-hmm. So maybe like have a look at different companies that have been audited by really reputable firms, and especially maybe use those companies to like interact with DeFi.
Mm-hmm. Yeah, good point. So like, and not to be doom and gloom.
Like Superform.
Oh man, I was gonna do a Superform demo, but it's just like it's too late. Like maybe next time. But we, it's going a lot better. A couple of years ago or a few years ago, like there was tons of hacks happening, like hundreds of millions of dollars getting stolen from these contracts. But I guess people are getting better at writing smart contracts, and also there's more emphasis on getting these audited. There's companies that exist just to like look at these smart contracts and make sure that these bugs and exploits don't happen. Nothing's 100% foolproof ever, but something like Aave, like I don't think Aave's ever been hacked. It's been around for like years. It's pretty solid, probably never gets hacked. So like these primitives, they're like pretty secure. I would trust them with my money. Some newer things, harder to say, but then you can look at, this has been audited by XYZ auditing firm, and therefore I can like trust it that there's been some really smart people that have looked and verified this to make sure it's not going to steal all my money or somebody can exploit it to do so. Good question. Good to put in. Yeah, maybe like a risks slide. This is V1 of Ethereum 101, and I hope that somebody else here can take it and iterate on it, maybe Tangle in the back there. Any other questions or comments? Yeah, microphone, please.
Hi. Can you hear me? Yeah.
I mean, I can hear you. Can the people in the stream hear you? Probably. Just talk. The mic is for the people on the stream, not for me. Yeah,
Got it. Sorry, I have, like social anxiety if I'm speaking, so I might ask you like a really dumb question.
You're doing great.
But first of all, really great presentation. I think the flow of the content was so helpful, like a true refresher, but in a very thoughtful flow.
Cool, thank you.
My question is a little bit like, could be dumb, but also a tricky question where, how you talked about the proof of stake and validators. Is there a possibility that, within cybersecurity, there's DDoS attacks that happen, right? There could be one programmer, like multiple programmers, or creating a network to, do their own agenda. So within the validators, is it possible that there might be bad actors that might allow someone who technically shouldn't be on it, and they just form a network and they're just like allowing each other? This could kind of fall under that tricky / risk, but I'm just trying to wrap my head around that.
Yeah. So it's a permissionless network, so anybody can join. And technically, yeah, if you had enough people, like a certain percentage of the network that was malicious, they can effectively do whatever they want and like alter the state of the chain completely. Maybe Yoni would like to take that question because he could do it. He could do a lot better job answering it than I could, and would love to hear it.
Yeah.
Mm-hmm.
Yeah. The collusion. Yeah. As long as they're not a majority, they would get socially slashed, I think, is the mechanism to deal with that. So they would be subject to other validators voting against them. So you have to control like some threshold majority to be able to do that. To be able to, well, it's really you're creating a fork, right? Because then you break consensus by having two histories. So you're maybe this like colluding group is saying like history should be this, like next block should have our transactions that are favorable to us.
Yeah, but even the mechanics side, like they have to be consecutive blocks being built by the.
Yeah. They're
otherwise, they cannot change it later, right?
Yes, there is some concept of finality where like it's not that they're rewinding history, but they're like doing favor like. Let's go back to like there was an issue early in Ethereum's history, which was about a DAO, like an organization that a hacker was draining funds from it over time, right? But slowly, and they voted to. This was before proof of stake, but they voted to kind of rewind that back. So imagine something where they're trying to. They're saying the rules should work a different way, right? Like this contract should operate the way we say and not the way the rest of the network says. That has to be like more valuable than their stake in some way, right? So they're putting up that bond, and they would get socially slashed, and eventually the network would overtake them because there's a rule that says it has to continue with like longest, heaviest chain, so like the most that are attesting to it, and it was building blocks the whole time, so. This is getting into the weeds of the like crypto economic security, but suffice to say, you have to have like a certain majority and like a lot of money in the form of Ethereum, like and willing to eat a certain loss to be able to do that. But there is a micro version of this, which is like MEV, right? Which is maximum extractable value. So. The ordering of transactions can be very valuable, right? Because like someone's going to make a certain trade or not, and you can front run them in some way. You can make a favorable trade before that happens, or you can reorder them so that maybe you're the provider of the token or either side of this trade, and that is something that you for various reasons you can't design that out of these systems. It always happens when there's public information, like there's a mempool where pending transactions go. Unless you can make it private and then everyone agrees on that private, like no one's cheating, then you're always going to have that in some way. So what Ethereum has done via this organization called Flashbots is kind of like distributed that. They've socialized it in some way where like you run something extra on your validator, like extra software, and it'll help you get a piece of that, like a share of that MEV. So collusion can happen like that in terms of like who relays the transaction, who builds the next block, and there actually are not many of those entities. So like they could collude and give each other better deals, but like they ruin their reputation that way. And then of course, like if they did something that was against the protocol rules, then the rest of the network could come down on them and do social slashing or deal with that stake in a different way. And they're always going to be like we're assuming that there's an honest majority, right? With regard to denial of service, the reason why that is not possible on Ethereum is because they have so many different clients. So they're different client teams, and they use different programming languages for their nodes, and then it's separated into consensus and execution. So you'd have to find a bug that's implicit to all of them, and it could be something like core to the protocol, but like it's very unlikely that 5 or more different teams implemented the protocol from the spec and then made all the same mistake, right? So like if it was just one single client, like maybe Bitcoin or Solana, then yeah, that is susceptible to denial of service or some kind of other bug, but client diversity guards against that. I think I covered that. How long was I goddamn talking?
That was good.
Yeah. No worries.
I also just checked here. So the total dollar value of Ethereum currently staked is $52 billion. So you can think if you want to try to do something malicious on the network by taking a majority stake in it, you literally need to stake, $30 billion to control the network. So, and then you have to be willing to potentially lose that money, right? So it's possible, yeah, but it's like, many, many billions of dollars. The same thing exists on Bitcoin. Like theoretically, you could spend enough money to control the entire Bitcoin network and do whatever you want. But it's just like billions and billions of dollars that you have to be willing to put up. And it might not. It basically is the economic value, like Yoni was saying, of this attack or this DDoS attack or whatever that you're trying to do, worth more than this money you're putting up to try to do that, right? And usually it's not. That's like the game theory behind these networks, typically.
You like delay it in some way, right?
Yeah, you
And
can.
You're like, well, why is delaying more valuable than, like why is delaying Bitcoin from doing something more than like temporarily, mind you, like for like an hour or something? Is that more valuable than whatever else you're doing, renting the miners or the compute? Like it never seems to work out unless you're like totally crazy, unless you're the Joker and you're like, I'm gonna set the pile of money on fire just because I can. But like there's not many Jokers.
The economics never really makes sense to do such a thing unless you're like intent on seeing the world burn, and nobody's like really attempted that yet. They could, right? Like some nation state could try to like put billions and billions of dollars and try to like shut down Ethereum. Is that worth it for them to do so? I mean, I haven't seen it yet. I hope it doesn't happen. Yeah, just fork it.
Thank you both.
Yeah.
Really good answers from both of you. So helpful.
Got it. Anybody else? Oh, good. All right. Thank you, everybody. Appreciate you coming out.
Yeah, you're gonna drop off.